or afternoon. Okay, so today we are doing another day of graphing. So we're going to solve systems of equations by graphing. So if you were in school on Tuesday, you would have this already. Please take it out. If not, take some graph paper out, take a pencil out, take some paper out, take your calculator out, okay? So the difference between Tuesday and today is that things aren't going to be in slope-intercept form. You're going to have two equations. Maybe one will be, maybe neither will be. So the whole goal is you need to get things in slope-intercept form. So this first equation here, I want to get slope-intercept form, which is y equals mx plus b. Okay, so what do I have to do? I have to minus an x to both sides. Okay, and I'm going to just draw us down here. Okay, so if I have that canceling out, I have y equals, now I want the x first on this right side. So I'm going to put a negative x minus 3. I could put minus negative 3 minus x, but because I want it in slope-intercept form, I want that negative x first. Now, please remember that's really a negative 1x plus a negative 3. These are the same equations, but this bottom one might help you graph a little more. So what does that mean? That means I start at negative 3 and I go rise over run, down and over. And remember that first line, we want to extend both ways through the graph, and we just want to make sure that's representing a negative slope. Okay, next one. I'm going to do keep, change, change, just to make sure that I realize that 4 is negative. And now I'm going to minus x. So this part, for those of you who are really good at getting y by itself, should seem really easy. Okay, so I'm going to kind of move this over here, and I get a negative 4y equals, now again, I want that x first, and it's not just negative x, it's really negative 1x minus 8. And again, I'm going to change that to plus the opposite, doing that keep, change, change. So when I divide everything by negative 4, it helps me keep those signs a little better. Now, negative over a negative is a positive, and again, a positive. So here's my second line. So now I'm going to start it up 2, and then I'm going to rise over run, and extend the lines. Okay, and I'm going to look. What is my solution? My solution is this point right here where the two lines cross, and that is at negative 4, 1. So back 4, up 1. So that blue ordered pair is actually my solution. Okay, take a look at that. Copy it down for your notes if you want it. Okay, next one. Here we go. So what I'm going to do actually is I'm going to recopy this equation over here. And again, I'm going to do that keep, change, change. Now I have some work, some space to do work. So first thing, I'm going to minus 4x to both sides. Again, the whole idea is to get it in slope-intercept form so I can graph. So I am left with a negative 3y equals a negative 4x minus 3, but that's really plus a negative 3. Remember that. And the reason I'm writing the 4x first is to keep it in slope-intercept form. Now remember, when I divide, I have to divide all 3 terms. So I get a negative over a negative is just a positive. I'm going to leave my slope as a fraction because we want slope to be a fraction, actually. And a negative 3 divided by negative 3 is 1. So I'm going to start here at up 1. Oops, I don't even know how that happened. Up 1, and then I'm going to rise 4, run 3, and I'm going to go in the other direction too. So I could extend that line because again, that second equation, you guys know, I'm not sure where it's going to go. Okay, let's do the second equation now. Okay, So I'm going to start by minusing 4x. After I do that, keep, change. So I get a negative 3y equals, now I want the x first, just to keep it in slope-intercept form. And then I'm going to divide, again, everything by a negative. I'm going to do that because when I divide by a negative, I don't want to lose a sign somewhere. Again, we have a negative over negative, which reduces to a positive, and the same thing here. So when I plot my second line, I started up 4, and then I want to rise 4, run 3, but I can't go up 4, so I have to go negative, negative. Okay? Now, here's what I want you to notice. Are they crossing? No. Look at their slopes. They have the same slope. So even though one is starting at y-intercept of 1, the other one's at 4, they're rising and running at the same rate, which means they will never, ever cross, which means my solution is actually no solution. Think about that. They're never going to cross. Okay, let's do a couple more. So again, I'm going to take this one and I'm going to solve it over here. So the first thing I'm going to do is do the keep, change. And this time I'm going to add 6x. And I'm going to do that to both sides of the equation. So now I am left with a negative 2y. And now this is a positive 6x minus 8. And I'm going to do that keep, change. And again, I'm going to divide everything by negative 2 and reduce. So it's y equals, now do you see that becomes a negative 3x, and that's a positive 4. So my y-intercept is 4, and I have down 3 over 1, down 3 over 1, down 3 over 1. Make sure it's a negative slope. And I'll say it again, that first line you really want to extend all the way because you don't know where the second line is coming. Now the second equation is a little bit easier because you have a y and it's a positive y. So all I have to do, if you notice, is minus 3x from both sides. So I get y equals, now again, I want that 3x first. And since 4 is positive, I'm going to add 4. Okay, so I'm going to start it up 4 and then down 3 over 1, down 3 over 1, down 3 over 1. Oh, what do you notice? Do you see these points are the same exact points? So that means it's the same line. So this equation, look, these are both the same equation. So this means your actual answer are all real numbers on the line. So it's not just all real numbers. Is there an infinite amount of answers? Yes. Is it all real numbers? Yes, but it's all ordered pairs or all real numbers that actually are on the red line and the green line. Any number because it's representing the same one. So it's all real numbers on that line because it's just like an overlapping red line and green line. So that means all of them work that occur on that line. Okay, last two. Okie dokie. So here we go again. I'm going to move this over here, but I'm going to start by minusing 3x to both sides. And now I have a positive y, which is awesome. And I have a negative 3x minus 4. I'm going to do that keep, change, just so I remember that that's really a negative 4. You don't have to do that. Okay, the bottom equation. Oh, I'm going to do that so I don't forget that y is negative. And now I'm going to minus 2x. Okay, so I get a negative and I'm just going to put a -1. So again, I realize that number is there. And now I have a -2x minus 1. But again, I'm going to do that because when I divide to get a positive y, I don't lose my sign. So y equals, this is a positive now, negative divided by negative, and another 1. Okay, so here we go. Oh, I forgot. Now let's graph this one. So we're going to start at down 4, and my slope is -3 over 1, but I can't go down, so I'm going to go up and back, up and back, up and back. And I just make sure that that is actually a negative slope, like it is in my equation. Now this one, again, starts at up 1, and my slope is +2 over 1, +2 over 1, +2 over 1. And I'm going to just keep going. And this is the type we had before. Do you see right there is where it crosses, and that's the ordered pair, back 1, down 1. So my solution is an ordered pair again. Okay? Okay, so hopefully you wrote down the examples or paid attention. Now your homework is the yellow worksheet. It says Systems Graphing 2, Worksheet 2. So take that out or print it if you weren't in school on Tuesday. Make sure you check your answers in Schoology, and make sure when you do today's formative, you have some graph paper out. It will require graph paper, okay? Okay, people, have a great day, and let me know if you need any assistance.